I'm going to talk to you all about my work on development of nanoprobes for in situ cancer marker detection, specifically MMPs and pH in 3D in vitro platform. As we all know that tumor microenvironment often presents altered physicochemical characteristics of extracellular matrix, such as matrix composition, stiffness, change in physical parameters like pH, change in temperature, etc. Of all these, uh, MMPs, overexpression of MMPs and extracellular acidosis are considered as hallmarks of cancer. MMPs are zinc-dependent endopeptidases that are involved in degradation of ECM proteins and activation of certain growth factors and surface receptors. The expression of MMPs is seen in many physiological processes like tissue remodeling or angiogenesis, but its overexpression is often associated with pathological conditions and disease states. Multiple types of MMPs are known to be expressed in cancers.
Wants to metastasis. In the early stages, it is not mentioned because the choice of release of MMP is only when cancer wants to progress to the other sides. Or also the growth phase, what you are taking into account, that is only seen in the core side, not in the all around the cancer, and that is also in the later stages. So how these imaging techniques can detect early cancer? Because both the parameter what we have chosen, which is not in the initial stage, which is rather when the cancer wants to metastasize, or when the cancer have got stem cells and
but in this case we're playing with the stiffness, and stiffness actually, as the cancer progresses and it is in the later stages, it is getting more stiffer. So here I'm actually doing that only. So if you see the earlier stages, there is very less expression of MMP, even if it is there. The faculty members have it.
So it's a nanotextured and drug-loaded Neovius PI6AL4V ELI scaffolds with osteogenesis and anti-cancer potential. And I'm going to discuss about this work today. So as we know, the musculoskeletal disorders comprise a very high number actually. And if someone is suffering from that, it will cost its quality of life and many things. And if you see, around 1.71 billion people are suffering from these diseases, and around 35% have mortality rate, means people are not able to survive. And even 5 year survival rate is around 69%. So in my current study, we are targeting one of the musculoskeletal disorder, basically osteosarcoma. And if you can see, femur is the very means more effective site for this osteosarcoma. And what is my problem motivation? Why I have started working on this is means continuing from this previous slide. This is the leading contributor to disability worldwide. Even in Indian population, right now it's around 12% of people are elderly population, and in the coming 20-30 years, right now we are very young country, and in the few decades, our population will convert to means elderly population. So people are going to suffer more on this musculoskeletal.
How is that that's how is the application of using food travel? Like he is feeding the cancer cell first, there it is setting oxygen system. If one drug contribution as or pipeline is not able to inhibit the cancer as practices. What is the reason of using how it is like,
this is a strategy where I'm showing how can I release successfully two drugs for a given application. The drug here I have chosen biacylin has two effects, but let's say you are using only a single drug, then this strategy might help in that situation.